It's a world of mystery. Do you really want to know?
Hello, this is Data. Hope you're doing well. Last month, in the journal Nature Communications, an article was published discussing the first ever observation of a space hurricane. What is a space hurricane and where did that happen? Somewhere on the North Pole, the top of the world, the center of the Earth on there, happened to be a space hurricane. It was more than 620 miles wide and high in the sky. It formed in the ionosphere between 50 and 600 miles up. And the information was created using a 3D model of the storm. This is the only picture that we have. This space hurricane lasted 8 hours and it swirled counterclockwise. The researchers said that it had several spiraling arms snaking out from the center, looking a little bit like a spiral galaxy. They plugged the satellite data into a computer model and they were able to reproduce the storm and figure out what caused it. They found that charged particles emitted by the sun's upper atmosphere, the corona, were to blame. The steady stream of solar particles and corona plasma is known as solar wind, and it moves about 1 million miles an hour. These space hurricanes must be created by unusually large and rapid transfer of solar wind and charged particles. As the solar wind reaches Earth, it encounters the planet's magnetic field. Earth had such a field because of the swirling liquid iron and nickel in its outer core, which gives rise to electric currents. The magnetosphere protects the planet from deadly radiation from the sun, but also retains a tiny layer of plasma from the solar wind. Solar wind usually glances off the protective sheath, but sometimes the incoming charged particles and plasma interact with either the trapped plasma or the electrical current generating the field. And such interactions create disturbances in the magnetosphere. This 2014 space hurricane was one such disturbance, and it is suggested that the interaction between the Earth's magnetic field and bits of the sun magnetic field transported on the solar wind, and that is what helped to form the storm. Usually these magnetic fields don't mix, but if they do come close, portions of the fields can get realigned and even merge, forming a new pattern of magnetic energy. This is what likely happened on the day of the space storm. An influx of solar wind formed a new pattern above the Earth's magnetic North Pole. The storm acted as a channel from space into Earth's atmosphere, funneling some electrons down past the planet's armor. This particle rain could have wreaked havoc on our high-frequency radio communications, radar detection systems, or satellite technology, because the charged solar particles that seep through the Earth's magnetic field can cause malfunctions in computers and circuitry on satellites, and also the International Space Station. Fortunately, in this case, no issues were observed.